Okay, let's go through another redox reaction, but this one's a bit This one's alkaline, so we're going to change the last steps. So everything's the same at the beginning. So let's classify our permanganate MnO4 minus going to MnO2 as 1/2 reaction, and then our sulfite ion turning into sulfate ion. Okay, so let's go through the process. Balancing 1 and 1, and then 4 and 2, which means I need 2 H2O to balance those oxygens. And now I've created 4 hydrogens on this side. And let's look at charges. +4, -1, 0, and 0. So this means I have a +3 on the reactant side, and I have a 0 on the product side. So I need to add a -3 on here. So that changes this to 0 for charges. And how do I get that -3? I'm going to add 3 electrons. And that means the permanganate, MnO4 minus, is gaining those electrons as reactants. And therefore, this is a reduction reaction, reduction process. Now we need to pair that with the oxidation reaction. So let's look at the sulfur, 1 and 1, that's good. We have 3 oxygens and 4 oxygens, so I need 1 water on this side to give me another oxygen. That means I need 2 hydrogens on this side to balance the hydrogens. So let's look at charges. So I have a 0, I have a -2, so this adds up to a total of -2. I have a -2, and I have a +2. And that gives me 0 on this side. So that means I need a -2 to make this total the same as the other side, the reactant side. So that means I'm going to add 2 electrons to this side, right? And now notice I have 3. Oh, and again, we've got then this idea that the sulfite ion is losing electrons, and this is an oxidation process. So we've got 3 electrons gained and 2 electrons lost. What's our common factor? We've got 6 is our common factor, so we're going to need to take this whole equation times 2, this whole equation times 3, and let's put these together now. So this gives us 6 electrons plus 8 hydrogens plus 2 MnO4 from that first line. Then I'm going to take that second line, 3 H2Os and 3 SO3s, 2 minus, and that gives me everything on the reactant side added together. Now everything on the product side, 2 MnO2s, 4 H2Os, and then on the next line, 3 SO4, 2 minus, 6 H plus, and 6 electrons. Okay, so we know automatically our electrons can cancel. Let's see what else cancels. Notice I have 8 hydrogens on this side and I have 6 hydrogens on this side. So I can cancel 6 of those hydrogens. So 6 cancels and I'm left here with 2 hydrogens. That's that difference. Notice I have 3 waters on this side and 4 on this side. So I can actually cancel 3 out of both sides. So that leaves me the difference here with 1 water. All right. So if we actually simplify this now, let's just write this out for ease. So 2H plus, 2 MnO4 minus, 3 SO3 2 minus, 2 MnO2, and 3 SO4 2 minus, oh, and the 1 water and H2O. So let's check to see that everything balances for charge. I have a +2, I have a -2, and I have a -6, which gives me a total of -6 on the reactant side. I have a 0, and I have a -6 and a 0, which gives me a -6 on the product side. So we know that it's balanced, and so we now have a balanced chemical reaction according to an acidified solution. So remember what an acid is. An acid, so this is acidified. because it's got hydrogen ions in it. And so those hydrogen ions are part of that reaction. What if we wanted to make it basic? So if it's in alkaline, alkaline means basic. What we know is that we know when we have H plus, we can neutralize it with a base. So if this is an acid and this is a base, we can actually get water. So that's a very typical acid base equation that shows us the H plus and the OH minus neutralizing each other. So you know that with a balanced equation, we can have the same things on both sides, which cancel each other out. So what if I took these two hydrogens here and I added 2OH to this side? But what I did to this, do to this side, I need to actually add it to the other side as well, plus 2OH. All right. And so in that process, what I've done is I'm taking these two OHs and two H pluses and I'm making two waters. So I now have two H2Os plus everything in the middle of this equation, dot, 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 plus two OH minuses on this side. Right. Now notice I also have in this equation an H2O on this side. I have one H2O on this side. So I can actually cancel one H2O and one of these two H2Os. So if I look at it this way now, I'm going to just write everything out. H2O plus, and again, everything in those, that's in the yellow, 2 MnO4 minus, 3 SO3 2 minus, going to 2 MnO2, 3 SO4 2 minus. The water is canceled, and I now have 2 OH minus. All right, and so now I have a new balanced equation that shows us that we don't have H pluses anymore. We have OH minuses. I can do a quick check. 0 minus 2 minus 6 is minus 8. 0 minus 6 minus 2 is minus 8. And the charges are balanced on both sides of the equation.